Okay, inverse trig functions. I'll probably do this in 3 videos, so I'll do sine, cosine, and tan. Okay, so we are investigating what is happening when we're finding the inverse of this function. So remember that an inverse function, x and y are switched, okay? So if we think about what the graph looks like of y equals sine x, okay? If I reflected this along the line y equals x, I would no longer have a function because it wouldn't pass the vertical line test. So what I need to do is restrict my domain. Okay, and it doesn't matter where you restrict your domain, but for this question, we're going to restrict the domain between minus pi over 2 and pi over 2. So we're just going to start off by just graphing y equals sine x between minus pi over 2 and pi over 2. Okay, so here's pi over 2, 0, and minus pi over 2. So hopefully you guys remember that sine of pi over 2 is 1. Sine of 0 is 0, and sine of minus pi over 2 is minus 1. Okay, so this is what, let me get my curve in there, that's what the graph y equals sine x looks like. So then if I do inverse sine, I need to switch x and y. Now, this is going to get a little upsetting because this is in radians but with pi's, but let's just convert it so it seems to make a bit more sense to us. So remember that pi is 3.14 divided by 2, so it's going to give me 1.57. So I actually have a point at 1.57 and 1. I have a point at 0, 0, and I have a point at negative 1.57, negative 1. So to graph the inverse function, I simply need to switch x and y. So this is going to have a point at 1 and 1.57. Okay, so x is 1, y is 1.57, so we're up here. Okay, 0, 0 stays 0, 0 because x and y switch, and 1.57 and minus 1 switch, so I now have a point at minus 1 and 1.57. So the graph really doesn't look that much different, but I guess the whole purpose of me showing you this is for you to understand that the domain of the function has to be restricted in order for it to remain a function. That's important to know when we're actually solving. So the domain of this function is between minus 2 pi and minus pi over 2 and pi over 2, and the range is between minus 1 and 1. And hopefully you guys remember that when you're finding the domain and range of the inverse function, then the range just becomes the domain, which makes sense because we're switching x and y. Okay, so there we go. All right, so that's kind of like the intro stuff so that maybe you can understand what we're actually doing. The main conclusion I want you guys to get out of this is that inverse sine of x is the same thing as saying sine y x. Those are equivalent statements, okay? And you need those equivalent statements to actually solve these questions. So let's get into a few that we're actually solving the questions. Okay, so inverse sine of 1 over root 2. So I'm simply going to convert this. So this is the same thing as saying sine y equals 1 over root 2, okay? So then we go to our special triangles. So I'm looking for where sine is positive, okay? So sine is positive here and here, but remember, I just restricted my domain to only exist between minus pi over 2 and pi over 2. So the only possible answers are in this quadrant. So I know for sure the answer has to be in this quadrant. And sine is y over r, so I know that this is a pi over 4 triangle. So y equals pi over 4. Okay, let's look at one that is a bit more fun. So this one's interesting. It's the inverse of inverse sine. Now, maybe you guys are having flashbacks of pre-calc B. And if you remember that the way that we proved that an inverse was an inverse, it should equal x. Okay, so if we plug a function inside its inverse, it should equal x, because inverse functions, like if I do x squared square rooted, it's like I just get to x. I'm back to where I started. So this should simply equal pi over 4. So let's just do it. What is sine of pi over 4? Sine of pi over 4 is 1 over root 2. Inverse sine of 1 over root 2, actually I already did that question, is pi over 4. So if you have a question like this, you can just skip to the answer as long as this angle exists within the domain of the function. You have to be careful of that. Okay, so that's sine.